So dear students, in this video we are going to discuss velocity selector. Velocity selector basically it is the motion of a charged particle under both electric and magnetic fields. So when a charged particle moves under the electric in the presence of both electric and magnetic fields, so we basically come across a situation and which is known as a velocity selector. For example, this is the direction of electric field which is along let us say J direction, and let this is the velocity of the particle which is basically along I direction, and this is the direction of magnetic field which is along the Z direction. So we have three things here: one, electric field along Y direction, magnetic field along Z direction, and velocity of a charged particle along X direction. Okay, so and we know about Lorentz force. So Lorentz force is basically force experienced by a charged particle under both electric and magnetic fields. So Lorentz force is the force experienced by a charged particle under both electric and magnetic fields. It is given by Q E plus V cross P. So this is the net force or the Lorentz force experienced by the charged particle which has a V velocity under electric and magnetic fields. Okay, now we have let us say, so here if you see it, here is a cross product between velocity vector and magnetic field vector, and in our case velocity vector is along I direction and magnetic field is along Z direction. So what V cross B will give us? It will give us V I cross BZ. Now we know Z cross I will give us Z is basically a K vector. It is along Z direction, so it is given by K unit vector. So it is, we know K cross I is our J. I cross K cross I is our J, but here it is I cross K, so it is minus J. That means Vi cross Bk will give us I cross K, which is minus J, so Vv minus J. That means V cross B is our minus Vv J. Therefore, what is our total Lorentz force looks like? It looks like Q E is along E vector is Ez, Z direction, okay, plus V cross B is nothing, it is minus Vb along Z minus Z direction, so minus Z. Now F will give us, if J comes outside, it is Q E minus VB along Z direction. So this is our net force experienced by the charged particle, or it can also be written as QEJ minus VBJ. So this is the net force experienced by the charged particle, where this part is our electric force, this part is our magnetic force. Now, as you can see, total force is the electric force minus magnetic force. That means electric force exactly opposes magnetic force, or magnetic force exactly opposes electric force. Now if your electric force, the value of the electric force is equals to the value of the magnetic force, then the net force will be 0, because electric force is along positive j direction and magnetic force is along negative j direction or y direction. That means the net force will be 0 if only if QE is equals to VB, or this force is equals to this force. So net force on the charged particle is 0 if electric force is equals to magnetic force. That is QE is equals to VB, or simply, okay, here is also one Q here, because Q multiplies both terms in the bracket. That is QVB. So QQ get cancelled, so V is equals to E by B. So this is the velocity of the particle when the electric force is equals to magnetic force. That means if a charged particle has a v velocity, then the net force of the charged particle will be 0. So if this v velocity of a charged particle is E is equals to B, then the charged particle do not experiences any force from both electric and magnetic field, so it will goes undeflected. If it has a velocity of E by B. That means it goes undeflected through both the electric and magnetic fields. So this is applied where if you have a bunch of particles and you wish to select a particular particle from the group of particles, if you have to select a particle which has a fixed velocity, so what you will do is you choose that velocity, or you select a velocity of the particle which you want to take. So and you accordingly make the electric field and magnetic field ratio of the particle to be the same. So if that happens, then you can exactly move that particle undeflected along electric and magnetic fields, and you can get the particle you want or you are desired to. So this particular process is known as velocity selector. So this is it for today. So tomorrow we are going to continue our class.